In the last lesson, we looked at limits as we approach real values. Okay, this time we want to look at as x approaches positive and negative infinity. You may remember that, or not, this has to do with the end behavior of a graph or horizontal asymptotes. Okay, I'm also going to review, because I have a worksheet that I made up that helps with those asymptotes. That kind of like goes through step by step how to find each one. But remember, when we talk about infinity, that symbol doesn't represent a real number. Okay? It's not a real number, but we use it to describe what's happening in the graph. So, oops. So it describes the behavior of the function.
Wait, when you say behavior, do you mean the behavior?
Yes, it's going to be specifically the behavior is going to be the end behavior. So what happens when we go all the way to the right on a graph and all the way to the left? Right? Without bound. What's that?
It never ends.
Right.
It approaches
You're not getting
So what we say is it approaches infinity. It can never reach infinity. What we were looking at yesterday were limits of real numbers. So we could actually look at the real number. We could look at as the limit approaches x equals 3. So we could look at the graph of x equals, right, where x equals 3. But today we want to look at what happens when we don't stop. We keep moving to the right. What's happening? Remember, what are limits? They're y values. So what are happening to the y values? So think about y equals a number is a horizontal asymptote or a horizontal line. Okay, so that's why if you look at going positive infinity, usually, well, some graphs will kind of level out, kind of looks like. They're never going to become completely horizontal, but it looks like it's becoming more and more horizontal to the right and possibly to the left, and maybe both. Are we okay? Mm-hmm. Make sense? Okay, so our horizontal asymptotes right here, like I said, I will give you a worksheet that kind of summarizes all this. As we approach positive infinity or negative infinity and we get a real number, that real number is a horizontal asymptote. Okay, so think about what I just said previously. If I have a graph and I'm looking at to the right and I'm never stopping, but the graph kind of becomes a horizontal line, that's the asymptote. Okay? Let's look at this example. Now, we can graph this on our calculator, but I have it here for you. It's x over square root of x squared plus 1. So let's look at the limit right here. As x approaches infinity, and then negative infinity. So let's look at positive infinity first. What's happening to the graph? So I'm kind of looking at this part.
Approaching 1 point.
Uh-uh.
Like the y value. I don't know.
Hold on. Bear with me for one moment.
That would be really cute.
Every once in a while, the pen stops working. Anyway, yeah, those are my daughter's spelling words. She likes to practice. She wanted to. I don't remember. What was on there?
Is that snows and foxes?
Foxes. Yeah, I think she had that. It was like she has like spelling words and vocabulary
I
words.
still remember in first grade. It's a funny story.
Okay, is it short? Is it
Yeah,
like less than
it's
30?
short.
Hurry.
We had a spelling test and the word was said, and I wrote it wrong, and then like I started panicking because she was coming around to collect it, and I erased something, and then I ended up writing sad, and I was really sad.
I'm sorry. That does sound like a really sad experience. Okay. Thank you for sharing. Thank you for sharing. Okay, so we are looking at the graph. So imagine this graph goes further and further to the right, and it doesn't stop, right? It keeps going to the right. And what is the y value getting closer and closer to? Oh, yeah, it's kind of hard to see on here, isn't it?
I mean, I did it on my calculator.
Yeah,
and
let's-
it's approaching 1 because it goes 0.998, 0.995, 0.995.
Because it extends past 1.
Let's see. Well, we can make sure. Here's the graph.
I'm sorry.
So one thing that we could do is we could just trace and move along, right, the line and see what's happening to the y values. So just looking at here, the y values are getting closer, 0.9836, so they're getting closer and closer to 1. It's never going to reach 1, but it's going to get closer and closer to that value. You could also go to the table and just plug in some numbers, but to the right, it's definitely going to be equal to 1. Now from the left, or to the left, I should say, approaching negative infinity is going to approach negative 1. Now, most of the graphs that we would look at, most of the rational functions, I would only give you one horizontal asymptote, but you could have two. You can have two asymptotes, like in this case, because the right, we would say the right end behavior is approaching 1, the left end behavior is approaching negative 1. Make sense? Okay, so the horizontal asymptotes are y equals 1 and y equals negative 1. Okay, now we're going to go to our calculators, and we're going to put this in. So we have 2x minus 1. Oops. Okay, so we're going to type in. We have 2x minus 1 divided by, we know how to get the absolute value. We go to math, over to number. First one, absolute value. And we want minus 3. Just make sure that you put parentheses around the numerator and denominator. Or unless you put it in the fraction, yeah. I purposely do it this way just because it depends on if you have a newer version or not, but you have to, I know.
I got the grandpa version.
Okay, go ahead and plug that in. And let's graph. I'm just going to put it in standard. Now remember, when we're looking at the graph, we don't care what happens around 0. We don't care what happens around 1 or at 2. We don't care about our vertical asymptotes. All I care about here is the end behavior. What happens as I look at x approaching positive infinity?
Y is approaching negative infinity.
What is the y value approaching?
Negative.
What do you think? Okay, how can we find that? We could go to we could trace. We could go to the table. So
I went to the table and
you went to the table.
and then it kept getting closer to 2.
Mine didn't work. The graph.
Do you have to find the stuff in the middle? Like, does that apply to what we're doing in the notes?
The approaches to the first one approaches negative. What?
Okay, if I had put in my table of values,
So I need to put
oh,
the
you
whole
need
thing in
parentheses around absolute
yeah.
value. Yeah.
Why does the
That
calculator?
approaches
Some of them
to.
says error, which if it says error, does that mean it doesn't go there? Therefore, it has to be 2. Yeah, there it is.
Hmm?
I had a feeling it would react, because I don't think this is right.
Okay, what am I plugging in now? You want to plug in big numbers.
Wait, I don't know how to plug numbers in.
Go to second, table set, change that to ask, the independent variable to ask. Okay,
How do I do this?
because then you can plug in whatever numbers you want.
I'm confused.
Did we get that?
Yeah, 2 and negative 2.
So, guys, when so what numbers am I plugging in if I'm approaching infinity? Well, I started off with 10, then I plugged in 100, 1,000, 10,000. My numbers are getting closer and closer to 2. Then what happens if I approach negative infinity? So I'm just going to type in negative 10, negative 100. Or negative 1,000, whatever.
And you're approaching negative 2.
And it approaches negative 2.
Approaches
Now, we have to be careful because your calculator can only round so much. So it will come out as -2, but we have to recognize that these are really small numbers, and so just,
Sorry.
what's that?
Online, if you just put in a bunch of zeros, it automatically tells you.
Yeah, that.
Doesn't give a decimal or
She
anything.
just said. That's what she just said.
Oh.
It's all good.
It's all
My
Are we all right?
ears are a little long.
All right. So,
So is your brain.
Oh.
what do we get as x approaches positive infinity again? 2.
All three Jones.
B, what did we get as the limit approaches negative infinity? So C, what are our horizontal asymptotes? They are 2. Okay, make sure you're writing y equals 2 and y equals -2, not x equals. And don't just write the numbers. They're asymptotes, so they need to be equations of lines. Good?
Got it.
Okay, questions? So remember, when I approach infinity and I get a real number, that's my asymptote, because that's the end behavior. If I approach negative infinity, you get a number. That's also an asymptote. What's wrong? Okay?
Wait, go up for a second. Thank you.
Who's this screen test? Not me. I'm leaving early.
So, but why do you need it now?
Cause I'm leaving early.
It's fine.
Oh.
She'll just fast forward through it,
Yeah.
or whatever. Skip to the part. We're at 12 minutes now.
What?
Well, she can like skip ahead to the time that she leaves.
Well, what's it called?
There's a page on your calculus page that says screencasts. There's only 2 of them so far. Well, yeah, the link is to you. It has the link right there. It's embedded, so it's right there.
Everyone YouTube channel?
Every teacher does.
Yeah, she does.
Through I didn't even know I had it until last year. I got this program.
Well, that's just because it's linked to your Gmail.
Right.
Yeah.
But we have as faculty, we have, so it was linked and then it was easy. What's that?
Oh, you should post one video.
Do you have a separate YouTube channel?
Yeah, you'll have to. No. Okay.
He does.
Properties.
Oh, yeah, that's what you want.
I swear to God, that's what I meant.
I do have a few other random, like the kids singing Frozen songs last year and stuff.
A little kid falls off a bike video, stuff like that.
There's a couple little things there.
Oh, wow, horrible.
All right, properties. Um, okay. So these properties, it's a lot of information. Let's just move on. There they are. Okay, we had a limit of sine x over x. Right. So remember, we had the limit as x approaches 0 of sine x over x was equal to 1. That was something that we had in the previous section. In this one, however, we are looking at what happens as x approaches infinity. Okay, well, we could graph this.
We should definitely.
So I'm going to put sine x.
Wait, why sine? Oh, we're not doing the problem yet, sorry.
I'm just looking at sine x over x. Okay, so now what happens with the graph? Well, we say it oscillates because it is going back and forth, but as we approach infinity and negative infinity, what are the y values? 0. Y 0. Okay, think about the numerator. The numerator is only going to stay between -1 and 1. We're never going to get out of a sine function something bigger than 1 or smaller than -1. think about the denominator. It's approaching infinity. So if I have like 1 over infinity, or negative 1 over infinity, or any constant over infinity, what is that? 0. So even though this is oscillating, like it's going, sine x goes up and down, right? So it stays between negative 1 and 1, but the denominator is getting increasingly large without bound. This whole thing is approaching 0. And actually, just to kind of a side note, the cosine's the same.
Cosine of x over x equals 1.
No, the 0. These two are identical because cosine also goes up and down from negative 1 to 1, but the denominator is getting increasingly large and without bound, so therefore the cosine over x is also 0. Now, before I get to the next part, I'm going to give you that paper I said about asymptotes. Okay, so do you remember how to find horizontal asymptotes by looking at the degrees? Okay, so we compare, when I look at rational functions, I compare the numerator and denominator. Okay, so like for example, the first one there, the numerator has a smaller degree than the denominator. Okay, so do you see on here? The very first thing I gave you were the top part of the page is for horizontal asymptotes and the bottom is for vertical. So the first thing I said, if the degree of the numerator is less than the degree of the denominator, then what's my horizontal asymptote? 0. Now, remember, what did I tell you limits as x approaches infinity are? So I compare numerator and denominator. As x approaches infinity, what's the end behavior? Remember, it all comes down to the degrees when we look at horizontal asymptotes.
So it's 0.
Yes, that
So
one's 0.
If the numerator is smaller, the degree of the numerator is smaller than the degree of the denominator, it's going to be 0.
Right.
Okay.
Okay, next one. We have 3x to the third.
So this should be 1.
Okay, this one falls under number 2. Degree of the numerator is equal to the degree of the denominator. So our horizontal asymptote is the ratio of the leading coefficients. So 3 over 2.
What it could be is
And then negative 3 over 2 also, right?
3 infinity over 2 infinity.
Okay,
Wait, Miss Casey.
so one of the things, I know that some people like to think about plugging in infinity, and if that's an easy way for you to remember it. I don't like to say plugging in infinity, because technically we can't, because it's not a real number. But basically what I'm telling you is when they're the same, it's like we ignore everything else. It's kind of like they cancel each other out. And we just have the coefficients that we're left with. Okay, next one. Now, next one we have to separate this into 2 limits. So I'm going to separate this into
3x over 1 times sine x over x.
No.
Wasn't that the easier? 'Cause
so
sine x
it's going to
over
be
x.
3x over x.
Can you not do it as 3x over, I mean sine x over x?
It's kind of like you working backwards.
Yeah, no.
We have to separate it into 2 fractions. So 3x over x plus sine x over x.
But there's only 1x.
Oh, but this is not if this was multiplication, then we would just put the x under one of them, but because it's plus, imagine if we had to combine these. What would you need? You would need a common denominator. Okay. What do we get for the first part? What happened with the x's?
3 plus 0.
Ah, so these cancel, so I'm just left with 3. This one is 0, so we get 3.
Can't you also do it as in they're equal, the degrees are equal?
Right, and then you could say the leading coefficient, so it would be 3 over 1. Perfect.
I have to go.
Okay. How about the next one? Okay, I'm going to separate this. Oh, this is supposed to say limit, sorry. Yeah, that was supposed to be there. That's a typo. Okay.
Where's
Come
Mandy?
on, I laughed at that. That was funny.
We've monitored it.
Bye, Miss Casey.
Bye, Maya.
Thanks, Maya.
Have fun.
I said bye to all, her, not us.
When you come back, you'll do.
Oh my god.
All right, so let's take a look.
I said when you come back.
Let's look at each part here. So I just separated it so that I think it's easier to do it this way than to multiply it out and then take the limit. Okay, so the first part, 1 over x. What is that? If we think about x approaching infinity, 1 over infinity is approaching 0. Plus 1, constants to stay, just like we had here, 3. Then here, look at the leading coefficients in the top and the bottom, because these two have the same degree. So we're just left with 4. So the whole thing just becomes 1 times 4. Right.
Wait, why is the 1 over x plus 1? Oh, because the infinity.
Yeah, the infinity. Questions? So this is
How do you get
approaching.
4 for this second parentheses?
So the degree of the numerator and denominator were the same.
Oh, so you just take 4.
So you just do 4 over 1.
And then minus 1.
The minus 1 goes away.
Oh.
Can you explain the first parentheses on the?
Yeah, this, okay, just look at the 1 over x. As x approaches infinity, the degree in the bottom is bigger. Think of the
Oh.
degree on the top is 0.
There's
So this is approaching 0.
Okay.
Plus, well, this is plus 1.
Yeah,
Like,
that's-
the limit of 1 is just 1.
Okay. If we were to make it, would it be helpful to make it x over x plus 1 over x?
That's fine. You'd still get the same answer.
X plus 1 over x, and then how would that work with the degrees?
Well, the degree of the top and the bottom would be equal, and it would be 1 over
That
1.
would be 1 over 1.
So you'd get 1.
Oh, 1x over 1x. Oh, cool.
Perfect.
Okay, so that
It would work either way.
That probably works better.
Okay, Matthew.
So,
Guys. Yes. That's what we're doing. I'm trying to show you that limits as x approaches infinity are the same thing as the horizontal asymptotes, which is why I just gave you that worksheet. Okay. The other one are limits as x approaches a value and you get an answer of positive or negative infinity. So if you get an answer,
For the limit?
right, the last ones we were approaching positive and negative infinity. Now we're looking at what happens if you get an answer of positive and negative infinity. Basically, these are vertical asymptotes, which we'll also look at. Okay. We can, remember how I said if it's infinity or negative infinity, it's also okay to just say they do not exist. Because infinity and positive, negative infinity and positive infinity are not real numbers, so technically they do not exist. Okay, but it's okay to write either one. Let's use graphs and tables. Let's look at these two limits here, x over x minus 2. So go ahead and put that on your calculator. Make sure, like I said, you always put parentheses around. Good? Okay, so we're looking at x approaches 2 from the left.
Negative.
What's happening to the graph? It's heading towards negative
Approaching
infinity. Right, it's approaching negative infinity.
Does anybody have a MacBook charger?
Which?
So,
Yeah.
just clarifying, if we did just write DNE and not negative infinity, it would be fine.
All right, good about that one. Next one has that greatest integer function we were talking about. So let's graph that.
Is integer just like round?
What's that?
What is the ing?
It's kind of like rounding down. I mean, that's the easiest way to think of it. It rounds down to the nearest integer. Okay, so let's graph that. Now, sometimes it's hard to see what's happening on the graph. So sometimes it's helpful to look at table of values instead.
Number 5. Where'd it go? I got it. Don't worry.
Can you go back to the slide?
What is? Okay.
You remember, you go math, go over to number, and then it's number 5. So it looks like from 0 from the left, what would you guess? 0 from the left? It kind of stops. So how could we check?
Oh,
We could
Zoom
go to-
box.
We could do Zoom box, or we could do the table. Now I'm looking at values closer to 0 from the left. So that's like negative 0.1, negative 0.01, negative 0.001. What's happening to my values? They're getting larger and larger. Do you think it's going to stop? One e to the 6 means 1 times 10 to the 6th power. Okay. So this is infinity. Again, we'll put does not exist just in parentheses, just a
So
reminder.
because you like the limits don't exist because you can't identify a certain number in infinity.
Zoom
Okay.
box is sick.
So vertical asymptotes, I put also on that paper I just gave you. Okay. So the top part of the page was for horizontal, the bottom was for vertical. So one of the things, if we get positive or negative infinity as an answer, as a result, that means the value we were approaching is a vertical asymptote. Think about that. Getting closer, does that make sense? We're trying to approach the next value, but all of a sudden the graph shoots up or shoots down towards positive or negative infinity, and it's never going to cross that, so that means that's a vertical asymptote. Okay? How do we find it algebraically? Well, first, I gave you step by step. All right, number 1. First, you want to write it in simplified form. So if there's anything that will cancel, in other words, if we can factor this and cancel something, we want to do that first. If you're able to cancel something, that means there's a hole in the graph. You may remember that from last year. So let's take a look. Does this one simplify? Well, it does factor, but nothing cancels. Step 2, factor the denominator. We already did. Possible. Number 3, set the denominator equal to 0 and solve. These will be your vertical asymptotes. So basically, x. Well, the 2, you could just divide by 2. The 2's kind of, whether you go back to 2x plus 4, set that equal to 0, or take this and set it equal to 0, either one's fine. The 2 in front doesn't have any effect on your asymptote. How about the next one? Does that factor?
You have to factor it. It's 5. It's x.
2x
5 and 1.
minus 3 and, or no, 2x plus 1.
But nothing cancels. So I'm going to set 2x plus 1 equal to 0, and I'm going to set x minus 3 equal to 0. So we get negative 1/2 and 3. So we have 2 vertical asymptotes here. Make sense? Oh, then describe the behavior to the left and to the right. Let me just do that for one. I only answered the first part. Let me just do that quickly here, because we have to look at the graph. So to describe the behavior, it just tells us, does it go to positive infinity or negative infinity? So if we plug this into our calculators, on the left, is it gonna go to positive or negative infinity? We know it's gotta be 1 because it's a vertical asymptote. We just have to figure out which one.
Since it was,
Yeah, so,
since it's like a negative side of 2, would that be negative?
not necessarily. We have to, that's why we wanna graph it real fast. So I'm gonna put in, x squared minus 1. And 2x plus 4. And graph it. So I just want to look at negative 2. Okay. So from the left, it approaches negative infinity. And from the right, it approaches positive infinity. That's not always going to be the case. It's not just because we're approaching from the left, it's automatically negative infinity. So again, this basically, this is the behavior of the graph. I'm not gonna, you would do the same thing for B, but you'd have to look at 4 limits because you have 2, basically you have 2 for each vertical asymptote, but we just look at the graph and see which ones are approaching positive infinity and which ones are negative infinity. Okay with that? Okay, so end behavior models. End behavior models are very similar to what we did with the horizontal asymptotes. We're just going to look at the biggest term of the numerator and the biggest term of the denominator and simplify it. So, and this kind of explanation, I put it in here, but I find that students find that more confusing. The simple explanation would be to simplify largest terms in numerator and denominator. Okay, so is it really?
Yeah.
Aw.
There's schemes outside your door.
That's not true. That's not Homer. It's fine. We have. We're gonna continue this.
Do we have class tomorrow?
No.
Unfortunately, no. I don't see you guys for a week. Can you believe
Long
that?
day.
Okay, you should be able to get through a lot of the homework anyway, but I put it all in there, but I'm not gonna collect it until the day of the quiz anyway. Okay, sorry. I keep forgetting that class ends at 11. It's what? 30, not 35 like it did.
Oh, it's all
Yeah,
different,
such a-
man.
Jay.
Such a
Alright,
great
guys, I don't see you for a week.
Have a great night.
really?
Yeah, shut up and
Dr. Jay.
Dr. Jay, please read me again.
Yes?
I didn't ask.
No, I know. Nobody wants to ask because they don't want to be offensive.
Oh, you are?
I'll say I am, but I wasn't
It's
always.
Dr. Dre.
Oh, you converted.
You don't speak my language. You haven't been to Cuba. Nor do you speak.
I'm one of those.
Shut up so loud.
I'm one of those.
Let's hear your Hebrew
I
accent.
switch sides.
No, it's okay.
What's that? I have none.
Oh, come on, you gotta have something.
Here, Idon and I are in the teacher cadets program. We can teach you.
I should learn. I need to learn. I learned the alphabet when I went to because I actually went through a bit of everything. So I learned like the alphabet.
You start by
I
going.
don't remember any.
You start by going. That's how you start.
No, not yet.
Southernish, Northern California.
We're exploring our options.
Or you take from like, we have a peek at Kansas, LA.
Yeah. Go like it.
Go to Heschel. Heschel's the best.
Heschel's the best. I only hear bad things about Heschel.
What are you talking about?
Only
Heschel's
Heschel.
the best highlight.
Heschel was awesome. I don't know who you're
Yeah.
Heschel was awesome.
How great is Heschel? Heschel's the best, right?
I think so.
There's no clear shit already. You're getting class.
Don't wear the numbers.
Only Okay, yeah. All right, guys. Come on in. Have a seat.
No, it's
All right, guys.
yeah.
What's AE, right? And what's Kadima?
AE Mine was the school I went to.
Okay,
and it was
Kadima
horrible.
is a public, is a
private
school.
I went there.
It's like right around the corner from here.
I went there too.
Mom, the school. It's Mom.
Are you serious, Tommy? Did you really just do that?
Tommy is the love of my life.
Okay. All right, so let's get our homework out.
I got an extra point. When is the homework due? Tomorrow?
Oh, I have the other one. The assignment number 9.
The homework is due tomorrow, right?
Okay, we are just a sec.
Rocket Mountain, you know what I had a question on my homework.
You were what?
All right, can we
Oh, the future pencil.
Thank you. Put it in my phone. Because I lost all my other ones. I was like, oh, Tommy has one.
let's have a seat and get our homework out and have some questions.
Don't think too much, just bust out. Sorry. Inappropriate school. Keep it
I just saw the bar.
I just saw the bar you drew me in the first day.
Alright, guys. So, yeah.
The state's going to binder downstairs.
Okay, hurry, go get it.
Can I write the question?
Yeah, you know. Just do it. Yeah, you know. It's just a birthday joke, like nothing like that.
Miss Kisa? Oh, Miss Kisa.
Yeah, her name is Mrs. She's married with children. Lord Almighty.
Can I turn my homework in tomorrow? I left that night.
The homework is due tomorrow.
Didn't we turn it in yesterday?
No, today. For last night. Last night's due tomorrow.
Yeah, but we don't have to turn it in right now.
Yeah, no, we don't.
Right, I just checked to see if you have it.
Wait, what?
Oh, I don't have it.
Here.
Mine's in my locker.
Thank you.
Mine's in my
I
locker.
did it.
But I did it.
I thought
You don't have
they're
any questions
due
on it?
tomorrow.
No.
I just put it in there.
Okay.
Because you did the answer page too. So like that was helpful.
homework that you were
Supposed to turn in tomorrow.
Oh, because I thought it was tomorrow.
Isn't it? Oh.
Wait, this assignment.
Leah.
Number
TBT
11.
to the crew.
Oh, so you
Who
did
did that?
That's quite century as well.
Because I thought it was
TBT to the crew.
Was that your whole class?
No.
Yeah.
That was
It's
just
always
the
due
crew.
the next.
Wait, so who's using the
Like, I check it every day.
Does he like
I
it?
just don't take
I mean,
it
kind
like
of.
collect
He
and
just
grade it.
does because
So it gives you the opportunity to
just concentrate on soccer.
So you don't have it.
He's just like me. Him and I had the
It
same.
does affect
We had
part
every
of your
single class together.
Yeah. If it's like
That means he's like on
twice a quarter.
I love it.
But if it were like every single day.
No, you can't. I was never given that.
I only did it once in my life.
So I did that.
I do that automatically. Yeah, just grab it real fast so I have it. Alright, I see 3 problems.
Oh, I also have a question. There's already a question.
Okay, okay.
But
I fell asleep during Hebrew. I've fallen asleep in at least one class so far.
So I
As long as
Tuesdays are so long for me. It's well, no, because I teach for bonus.
I saw you.
So I teach first, second period I teach, and then I teach straight through bonus. And then, so what page is the homework on? What, anybody have the page number it was on?
it was on page 50.
52.
I have a comment. So, yeah, today's also a really long day for me because I work from home at 8.